Howdy! This is your friendly neighborhood physics teacher here, and we're going to talk about mirror calculations. So this is for your Thursday, April the 30th, last day of April. So for your calculations on Thursday, on April 30th. And we have two equations to talk about. We have the 1 over your f, which remember that is your focal point, equals 1 over your distance of your image, plus 1 over your distance of your object. So D does so, let's see here, put it down. So your little fancy little f, I know, because we're like, well, you did a fancy little f for frequency. We're running out of f styles, I know. Well, this one, your f stands for focal point. Focal, I can spell, promise. Focal point, actually I don't promise, I can't spell, y'all know that. Your DI stands for your image distance. Image distance, and your DO just stands for your object distance. Now remember, your object is the actual thing that's producing the image. So if you're looking in the mirror, you are the object, and your image is your reflection. So our next little, and so that's, you can find your focal point, your image distance, your object distance, whichever what you're looking for. Normally 9 times out of 10, what you're looking for is your image distance. Because since the most mirrors are spherical, you can figure out your focal point, your focal distance. And then for your object distance, you can just measure the object from the mirror. So 9 times out of 10, you're looking for your image distance. Your next equation is your magnification. So M stands for magnification. Magnification. You know if I misspell it, y'all got that. HI stands for image distance. There's an A in there somewhere. No, image height, sorry. We're dealing with H. So height. Your HO is object height. And again, your DI and your DO are the same. So reference, come on, pen. Or don't reference, whichever one the pen's not, there we go. Reference back to those. Again, image height is the height of your reflection. Object height would be your height, or how much of you is in the mirror. If you're just looking at a mirror like you're looking in your bathroom, you're not going to measure your whole entire height. You're just going to measure your height as much as the mirror can see you, so probably from your waist up. So those are the calculations. So let's kind of get here and let's draw a few mirrors. So the first mirror we're going to look at is just a plain old regular mirror. So this is a plain mirror or a flat mirror. We're going to have a person standing here. If they have a height of, let's say, 3 meters, a height of 3 meters, and they're standing a distance of 2 meters. For a plane mirror, because there is no curvature, there is no focal point, all that fun stuff, for a plane mirror, your reflection, for just a plain old mirror, Joe Blow mirror, come on, change colors for me, thank you, is going to be, all of a sudden my thing's not working. Your distance is going to be 2 meters, and your height is going to be 3 meters. So this is for a plane mirror. Everything is going to be the same. For a plane mirror, everything is going to be the same. That's why we use plane mirrors to kind of check ourselves out, because what you see is what you get. Now, when you start going into, like, let's say a concave mirror, you have to sit there like so. Let's guesstimate and say our focal point is there, and then we'll say our, center is there. And actually that is not accurate for what I drew, so I can redraw it. maybe I can redraw it. Something like that. Now, you can place your image either in front of the focal point, between the center, on. There's all kinds of different things that you can do. But, so let's put our image here. We're just going to use an arrow. So the first thing you're going to do, you're going to draw a straight line to your mirror. And then you're going to do the best of your ability, and I'm going to do the best of my ability since I am doing this on the computer. You're going to draw a diagonal line that crosses the focal point. Pretty darn close, crossing the focal point. And remember, don't forget your sight lines. And then you're going to draw one that crosses the focal point and then goes straight out. Again, don't forget your sight lines. And where those two lines cross is where your image is going to be. And so your image would be there because they crossed there. Pretty cool, huh? Now, a couple of things to remember. If it's on this side, it is real. This side is virtual. I misspelled that. Up here would be upright. This is inverted. So it is a virtual upright image. So this would be a virtual upright image. Cool, cool. So then to do the calculations, I would have to give you a couple of different things. So let's say that the distance, just make it easy, 2 meters, and the height is a meter. So I'm saying it's your HI, not HI, HO is 1 meter, and your DO is 2 meters. And let's say our focal point is 3 meters. And we want to figure out, I got colors here. We want to know that. We want to know that. And of course we want to know our, so we want to know our DI. We want to know our HI. And we want to know how much it's magnified by. So first equation we're going to do is 1 over our focal point is 1 over our image distance plus 1 over our object distance. So 1 over 3 equals, we're looking for our DI plus 1 over DO. I'm going to bring this over to subtract. So we get 1 over 3 minus 1 over 2 equals 1 over DI. You need to find similar denominators, or you can sit there and put in the calculator. But we can do 6 is similar for both of those. And so it'd be 2/6. And that would be 3/6. Because if you simplify it, that goes to half, that goes to a third. That still does 1 over DI. You can now subtract them, so you're going to get a negative 1 over 6 equals 1 over DI. Now you never want what you're looking for on the bottom, so you're not done here. 1/6 is not your answer. You actually need to get your DI by itself, and there's 2 ways you can do it. So I'm going to show you both ways. First way is very mathematical, so you don't want your DI on the bottom is being divided, so go ahead and multiply it by both sides, so you get that your I is times your 1/6, or you can write it a negative di over 6 equals 1. We want our di by itself, so we can go ahead and multiply both sides, and I would say go ahead and multiply by a negative 6. Bring that negative over. And you get that your di equals a negative 6. And remember, that's in meters. Or you can just see that if I flip what I do to one side, I gotta do the other. So if we flip one side, we gotta flip the other. So either one, so you just flip both sides. So you still get the same answer. So you get your di as negative 6. Now if we're looking for our hi over ho equals a negative di over do, we're looking for hi. Our ho was, what did I say it was? Was 1 equals our negative 6, we just figured that out, over do, which was 2, right? Yep, 2. So you get that your hi, because 1 can just go away, equals, that becomes positive, 6 divided by 2 is 3. So your height is 3 meters. If you want to figure out the magnification, you can either use your hi over ho, or you can use your negative di over do. Either one works. So we'll do both. So we get a 3 over 1. So you get that it's magnified by 3, or you get a negative 6 over 2, and guess what? You get it's magnified by 3. So either way, you get the right answer. So that's kind of how you work it. And so yeah, let's do, so that's a concave, let's do a convex, just to work it out again. So we'll do this, we'll do a, oops, made it too big. Let's try that again. So in this case, remember our focal point is here, and so our center would be somewhere around there. And if our image is there, you still are going to do a straight line, but then a diagonal line through the focal point. Now remember, this side, the reason I'm doing dot, dot, dot is because that's our virtual side. And so that's our sight line. This is reflecting out. And then we'll do a line diagonal through the focal point. That's going to be kind of hard to eyeball. And then a straight line out, continuing on this side. There we go. And so, again, that gives us, if you remember, because this side is real, this side is virtual, up here is upright, down here is inverted. So that would give us a virtual upright image. And again, you can sit there and do the exact same calculations. And that's pretty much all you're going to get for a convex. It's just that. Now your concave gets a little more complicated. So we're going to go back to the concave. So your concave can get a little bit more, let's try that again, a little bit more complicated. So again, we have our focal point, and we have our center. So let's say, so we did in front of the focal point, is that what we did? Yep. Let's see if we do it in between the focal point and the center. So again, you just draw a straight line and a diagonal through the focal point. Then you do a diagonal through the focal point. And then a straight line. Your image, now focal point crossing doesn't count because of course it's going to cross through the focal point. Your image, I'm going to erase that C real quick, is going to be right there. So again, if you remember, this side's real, this side's virtual, up here is upright, inverted. So this would be a real inverted image. And you can just see, so I just wanted to show you something because I didn't realize both my practice were going to give you a virtual upright. So you do get a real inverted image, and you can get different things. So hopefully that helps. If you have any questions, please let Miss Heath or Miss Verona know. They'll gladly answer. Hope you have a wonderful day. Bye!